In this video, we're going to explore the absolute value family. Again, the absolute value family, the parent function, is y equals the absolute value of x. A good reminder, we're going to define the absolute value function and to help make sense of some of the things when we look at the graph and some of the characteristics by a piecewise function, in which the absolute value of x just equals x if x is not negative, greater than or equal to 0, and equals the opposite of x if x is going to be less than 0. So this will give us the following graph. As we look at this, we can see this idea of a piecewise function. We've basically broken it into two pieces, one line going up here, one line going down there. We can separate these by putting a line right down the middle. This is where I split into my two pieces. X is greater than 0 and x is less than 0. And we can see we also have symmetry going on, which is kind of nice. So this line here is our line of symmetry. And it would be x equals 0. We also, just like we had with our parabola, which also had a line of symmetry, we had this turnaround point, which we call the vertex. And in the parent function, the vertex is 0, 0. So because we have that symmetry, we also have that same BOGO effect going on. That if I pick any point on the absolute value, it has an evil twin or a mirror image on the other side. So when we solve these equations, this is why we get two solutions. Again, when we look at domain and range, my domain, just like with a square function, my domain is going to be all real numbers. But my range is going to be limited. My range is y has to be greater than or equal to 0. So again, it's possible to get no solution, because if I end up with an absolute value has to equal a negative number, well, that's kind of a no-brainer. The absolute value is always giving me my distance from 0. It's a positive value, so it can never equal a negative number. Now, one of the other things with this is, since the sides of the absolute value, we get a v, we have straight sides, we can treat these like lines. That's this idea with this piecewise function. And if we look at this line, y equals x or y equals negative x, that can translate over here to, when we have y equals x, that means my slope is going to equal 1. When I have a negative x, my slope equals a negative 1. I can see that there. This will be nice when we look at dilations, because it's easy to see the dilation of a line. The dilation of a line is a slope. Since the absolute value is just two lines put together, I can see the dilation in looking at the slope of these lines. We look at this graph here. Again, my parent function is the absolute value, because we see we have the V shape. We definitely have a piecewise with straight sides, so we know this is what we expect for an absolute value function. Woo! Undo that. Absolute value of x. We look and we see we do have a translation, because instead of the vertex being at 0, 0, we went right 4 and we went up 2. So we can describe that. So we can say we have a shift right 4. So my h equals 4. I can go up 2. That's my k. This one does not have a reflection, because it still is opening up the way we expect the parent function opens up. So we would expect, no, is this not, oh, I see. Parent function is opening up. Oh, let's undo that. I did not want that. So that's pretty much what we would expect there. But we do have a dilation. Because when we look at this line, we don't have a slope of 1, which is what the parent function has. I have a different slope. So let's look and see what the slope of this is. Make a little slope triangle. I went up 2, to the right 3. Up, and we still go up 2, right 3. If I look over in this direction, I go up 2, left 3. Up 2, left 3. So I still have that same slope, but this one is a positive slope. This is a negative. I kind of expect that because they're reflections of each other. So I can say this has a dilation. And when we talk about absolute value, it's generally best to think of it as a vertical dilation. You can do horizontal dilations, but they're a little bit more confusing. So we're just going to say I have a vertical dilation of 2/3. So that means I'm going to have 2/3. That's not a 2. 2/3 times my absolute value. Inside my absolute value, I shifted right, so I'm going to have x minus 4. And then I have my up 2, so I have y minus 2 equals 2/3 times the absolute value of x minus 4, or y equals 2/3 times the absolute value of x minus 4 plus 2. Let's just do one more example. In this one, again, it's very obvious. I have my parent is y equals the absolute value of x. Even when this is obvious, it's a good point. Start down, write that down, see what you have. I'm going to look at my shift, because I can look at the vertex to see how I am shifting. So I went to the right 5. I went up 10. So I have right 5, up 10. So I have the absolute value of x minus 5. I have y minus 10 equals the absolute value of x minus 5. Now, I have a vertical reflection. Because it's not opening up the way I would expect it. It's opening down. But again, here's a nice thing about looking at these lines. It's also not has a dilation going on, so I'm going to look at what slope I have here. And I have a slope of down 3 as I go over 1. You notice my slope is a negative 3 on the right side. Normally I have a positive slope. If it's going down, I have a negative slope. That negative gives me both with the dilation and the reflection. So if I can figure out the dilation, the reflection just kind of comes in with the wash. Because if there's a reflection, the dilation will end up being negative. So this has a vertical dilation of negative 3. So I'll put out negative 3 in front of my absolute value. Or in other words, my equation is y equals a negative 3 times the absolute value of x minus 5 plus 10. Finally, let's graph one of these. So let's graph y equals, stay on there please, that's y equals, that's going to go 1/4 times the absolute value of x minus 2, And let's go -5 from that one. So again, I'm going to start thinking, what's my parent? I see my absolute value right in there, so I know my parent is just y equals the absolute value of x. I look for my translations or my shifts. And so I see here, I'm going right 2. Here I'm going down 5. Then I look at my dilations. And I have a dilation, a vertical dilation of 1/4. And since it's positive, I have no reflection. So now to go ahead and graph this, I'm going to start with my translation. Right 2, down 5. Gives me my vertex right here. Now, since I know this is an absolute value, it's a piecewise function with straight sides, and I know the dilation is the same as the slope, I can just start at my vertex and do a slope of 1/4. So up 1 to right 4. Up 1, right 4. Up 1, right 4. And I can either use the fact that, hey, it's symmetrical, so I can just use my BOGO. Every point I can reflect it over to the other side. Or I can just go with my slope, 1/4, my dilation, means up 1, except I go to the left 4. Up 1 to the left 4. Up 1 to the left 4. Either way, there's my graph. Piece of cake.